Welcome back. It's been a while since I've done a detailed video like this. I'd like to show you how I made this lap desk with a secret key compartment using traditional woodworking techniques, some intermediate metal working skills, together with the shaper origin to give you my take on a classic piece of shaker furniture. Whenever I go to Lowe's or Home Depot for any sort of errand, I have this tradition of checking out the pine boards in search for a perfectly quarter-sawn piece of pine. A lot of us start using pine as a beginner in our woodworking journey mostly because it's cheap and easy to find. And as we gain more experience, we start using more expensive hardwoods. But what I've noticed is after a while, we all tend to go back to using pine because by then we know how to select boards, we feel confident in our joinery skills, how to sharpen our tools, and know how to apply finish to our projects. Despite what one may think based on the bent and twisted 2x4s on the shelves, pine is one of the most stable woods, smells wonderful, easy to machine, and planes well. And I can't think of another wood besides cherry that develops such a nice, rich, deep color over time. Joinery starts with a deep gauge line, which also helps us create this little groove to make transferring the tail to the pinboard much easier. I find that a full-scale drawing of the desk is very helpful for layout and to ensure that the dovetails are the same size at all corners since the desk has a slant and is narrower at the front. Some will say the dovetails I'm creating here will cause the pinboard to be too fragile and weaken the construction. The reality is that there is not much force being exerted on these joints. There are many examples of furniture with these so-called London-style dovetails that have survived for several generations. So, in this instance, I am willfully sacrificing a little bit of strength purely for aesthetics and to say that yes, these were hand cut. And here we see how that groove is helpful in aligning the two boards. You can see I'm starting off by scribing on the right side of the dovetails. And for softwoods, what I found out through trial and error is to shift the tailboard over just enough to cover the scribe mark before you start scribing the other side. I find doing this creates really nice fitting joints. Usually this step is done in pencil, but since the pinboards come to such a fine edge, I wanted to cut through any fibers that may be wandering off the vertical. Even in this case where we have nice straight grain stock to work with, pre-scoring helps prevent any fragments from chipping off at the face of the board, especially on the pull stroke of the saw. Here I'm using my fret saw to remove the bulk of the waste, staying as close as I can to the gauge line. I find that with pine there is a tendency for the center of the board to get some tear out the more waste I leave behind, even if I chisel from both sides and meet in the middle. In addition to cutting close to the line, a freshly sharpened chisel with a lower angle helps a lot too. When I first started cutting dovetails, I would purposely saw away from the scribe line and chisel to it for fear of creating gaps. But it took a long time to do one joint. I eventually got in the habit of sawing on the scribe line, which reduced the amount of time needed to pair the pin sidewalls. But even still, some whittling is needed for the parts to come together. I did want to spend some time on the joinery process around the side drawer opening. I think the first inclination is to just cut the opening all at once. The concern is that if you do that, and if you've ever cut into a piece of wood before, occasionally you might have experienced the blade being pinched by the wood, and when you remove your saw, you'll notice that the saw kerf seems narrower at the start of the cut, which is a sign of internal tension within the wood being released. And so if we go ahead and cut the entire opening, that single dovetail could deviate, and as a result it'll throw not only the case, but the drawer at a square. Now that we have the joinery complete and established how the boards fit with one another, we can now cut the rest of the opening. Since we removed part of our reference edge, we can't use a marking gauge. And so this is a method to ensure that the scribe marks made on each side line up with one another. The next step is to find a piece of offcut to grain match for the face of the side drawer. And this might seem a little tight for now, but just as in regular drawer construction, the drawer face is only going to get smaller as we fit the assembled drawer to its opening. The next order of business is to create a slot through the side of the drawer, which will later help keep it in place, and what gives this drawer the ability to fully open without tipping. If your face vise thickness is uniform, you can use it along with a router fence to cut this slot quickly, safely, and accurately. And since my bit was too small, the first cut made should be closest to you so that the second pass is a conventional cut and not a climb cut. Since this piece is relatively small, bringing it to the router table is a bit dicey. You'll notice that the top plate of this lock set is too wide relative to the thickness of the board. And if I mortise into the case front with the hardware as it comes stock, it will leave a thin, fragile web of wood that is prone to breaking off. So all I'm doing here is showing how to use a file to remove a little under 1/16 of an inch off of each side while maintaining square edges. And if you take your time, you can get very precise without the need for an end mill or dedicated machinery. This works out nicely because I wanted a lock set with square ends to make it look more traditional, and so I took off just enough to get rid of the radius and still keep the original countersunk holes using the same principles of a shooting board to maintain squareness after removing the bulk with a hacksaw. Because the desk is constructed on a slant, I had two options when insetting the lock. Either create a flat surface to mortise the lock into, or to file the top plate of the lock with that same angle. The problem in my head with the latter technique is that it would create an oval-shaped countersunk hole, which meant I would have to file the screws flush or recess them deeper. I opted to create a flat area instead, and the origin makes quick work for creating the pocket for the lock. And for the second mortise, to accommodate the plate, I used a downcut bit to prevent any tear out. So what I'm trying to show here is my thought process on how I went about making this escutcheon plate. I could only accommodate two screws, and I'm trying to determine where I can place them by drilling into the brass body without it interfering with the actual lock mechanism. And so that's why you see a few templates that didn't work out in terms of spacing and aesthetics, as the holes wouldn't be equidistant from the edge of the plate. The inspiration for this part of the project came from a trip I took with my wife to the Art Institute of Chicago, where I noticed a lot of damage in the area around the keyhole opening of a box that was also constructed of pine. After that trip, I felt like it was within my skill set to make one. To align the escutcheon plate, I began by drilling two small holes big enough so that the key would fit through, and I would use this to align the plate by eyeballing for a uniform gap around the keyhole relative to the key. Once satisfied, I placed reference blocks around the plate, and this allowed me to double stick tape the plate to the board in the correct position. The rest is the usual scribing and excavating out the waste to create the mortise. All that was left was to drill the through holes and tap the body of the lock to secure the two parts. This segment will become the pen tray within the lap desk, but it will also form the upper partition of the drawer for the secret key compartment. And here I'm demonstrating how a mortise is generated, which will help secure one of the drawer sides. This is a technique called silver soldering or brazing. And honestly, the hardest part out of all of this is how to hold the pieces in relation to one another while you bring everything up to temperature to melt the silver solder and have it flow into the joint. The next order of business is to drill for the hole for the button. This type of work is where the shaper origin shines. First off, you can place the hole exactly where you want, provided you grid the origin accurately. The second reason is the infinite adjustability of the hole you can generate, which is helpful for dialing the fit of the button. And third is repeatability. I actually lined the hole with ebony at first, but it looked too Bauhaus inspired, which wasn't the look I was going for. So I was able to route out the sleeve of ebony and insert a maple one instead, as I had not changed my reference setup on the shaper workstation. This fit is to show what you can achieve with literally a hacksaw and files, which you probably already have at home. I did have to purchase a small tap and die set to make this tiny screw to secure the two parts together. The rest of the drawer components are also secured using wood screws in the event I need to go in and make any repairs in the future. These glue blocks are well worth the time needed to make them. They ensure that pressure is placed exactly where it's needed and makes glue up much easier. The additional benefit of tails and pins that sit slightly above the surface is to plane away any glue that may get soaked into the end grain, which will show up as splotches when you apply finish. And here I'm pre-scoring fibers on the back side so that when I plane it flush, there is little chance for tear out. I use the Shaper Tools Studio free software in order to generate the template for this key tray, and these are some of the design iterations on how to retrieve the key from its slot, and the one that you see here is the design I went with. I need to make what I call a partially threaded hinge pin. I need a section that is straight and smooth and a portion that has wood screws on it to secure it into the body of the secret key tray. Threads on a wood screw are difficult to create since they are made through a process called cold rolling, and they aren't actually cut into the brass, and this is the process I came up with, which was to fuse two parts together. To cover the end grain of the secret tray, I grain matched an offcut as best I could, and since we have a cross grain situation, even though it's a short width, I attached the two parts with a sliding dovetail. I initially thought about using a single plain sawn board for the top and bottom for some variety, but plain sawn pine moves more during seasonal changes than quarter sawn pine, which could interfere with the alignment of the lock relative to the clasp in the lid. Therefore, I decided to go with quarter sawn wood instead for its stability. I created the mortises first on the breadboard ends using a router and router box. And after that was complete, I then used my router table to make the tenons fit by taking incremental passes. The stub tenons are created using the stop block setup here on my table saw, and since I decided to apply breadboards for both the lid and the bottom, I had 4 sets to do, and with the setup, as you can see with the video playing at normal speed, it makes fast work out of the job. And since the layout of the tenons is symmetric, you just simply flip the part around to create the other tenon without having to make any changes to your setup or any additional layouts for the subsequent boards. I took a little bit more care creating these shoulder cuts by pre-scoring with a marking gauge, as any gaps here would be seen. And finally, to ensure the joint between the breadboard and top is always tight, I planed a concavity at the center of the breadboard to create a spring joint. Since only the center section is attached with a small amount of glue and a wooden dowel, the outer tenons are secured with oblong holes to allow for wood movement. Here I'm careful to apply glue only to the maple breadboard end itself and not into the joint, as I want the two pieces of wood to move freely relative to one another. The overhanging pieces of maple ends are trimmed off using the spacer trick, and to finish off the lid and desk bottom, a thumbnail profile is created by using only a small portion of a roundover bit. At the beginning of the project, I was fully prepared to hand engrave the button, but with so much invested into making that part, my confidence shrunk at the thought of having to remake the part if my hand were to slip. Besides, it's hard to beat the accuracy and speed of the Origin. I additionally needed a deeper engraving to be able to blacken the letters. I initially brought the button to a high polish, but it looked too mass-produced and mid-century, which I'm also a fan of, but looked out of place for this piece. Instead, I fumed the brass parts with a mixture of sea salt and vinegar to give the pieces a bit more warmth. The bottom is secured with fasteners should I ever need to access the latch mechanism for future repairs. Since the bottom was so thin and the hole so close to the edge, I spent an afternoon making these brass conical washers, only to find that Lee Valley sells 10 of them for $13.40. But they were stainless steel and would have thrown off the uniform look in an area no one would look, but to satisfy my OCD tendencies and keep the woodworking commenters happy, it was worth the time investment. To ensure that the top lid makes contact evenly around the case, you can use a feeler gauge to determine the largest gaps you have, which in our case is 5/1000th of an inch. In conjunction with the depth stop on the router, you can remove that same depth of wood so that the hinges sit slightly deeper and thus decrease your gap. That way you won't have a situation where the left side of the lid is touching first and the right side is still hovering off a millimeter or two. And with that minor adjustment, the gap is now barely 0.02 of an inch. The latch needs to be mortised into the lid at an angle so that it sits even with the lock plate. To do this, we will need to create a wedge of the same slope to help us route at the correct angle. To then locate the latch in the correct location, I'm using a piece of wood with double-sided tape that I am going to butt up against the latch, which will then serve as a reference mark for the shaper plate. All we need to do is square up the edges of the mortise. The length of the screws are a bit too long, and since I plan on placing a ledge on the lid top to prevent papers and pens from sliding off, my plan was to place the pencil stop directly over the screws. Therefore, I drilled through the top and routed a groove directly over the holes so that the screws have more wood to hold on to. And by using a template instead of a router and a fence, I don't have to worry about the router base scratching the finish. I can't believe you guys are still here. Thanks for staying all the way to the end.